This tutorial is going to be about how to set up and cut some of your designs with our FabCut CNC plasma cutter. First thing we're going to do is we're going to review safety. Once we've reviewed safety, we're going to talk a little bit about how the plasma cutter works. I'll show you a little bit to do with the FabCut software. And then I'll show you how to take your material and set it up on the machine so you're ready to cut it. In order to stay safe when we're using this tool, we have to mitigate quite a few hazards. The first thing, before powering up, we're going to make sure that we're wearing a number 5 shade welding helmet, and that is to protect our eyes from the welding flash. We're going to wear insulated welding gloves. That's to protect our skin from the welding flash, but also protect ourselves from some hot material burns. We're going to cover up our arms with the welding jacket. That's the same hazard. We're looking to mitigate the welding flash as well as protect us for some hot materials. We're not going to cut in polyester clothes because if we get some sparks on our clothes, it can cause our clothes to light on fire. And we're going to ensure that our pants are over our boots. And if they're tucked into our boots, we have to wear spats. And that's because those sparks could then land in our boots and burn us. In the cutting area, we need to open the fume hood and turn on the fume extractor. That's because we're trying to mitigate the poisonous fumes that are released when we're cutting. We need to ensure that the work area is clean and free of grease or oil or flammable materials. That's because the sparks that are created can cause a fire. And we need to ensure that other people are protected from our welding flash. And we do that by adding some curtains, some welding curtains, or erecting some welding screens. And that's to mitigate the welding flash hazard for other people in the shop. On our material, we need to ensure our work lead makes firm contact with the welding material. And this is the work lead right here. We actually have a magnetic work lead that you're going to use. And we need to ensure that the ground clamp and the hoses don't create a tripping hazard. So we're trying to mitigate the tripping hazard. Lastly, this CNC welding table will be filled up with water. And some of the water will spill out over top of the table. So we need to make sure that we mop up all of the water that spills onto the floor. And we're doing that to prevent people from slipping when they walk by. Of course, one of the hazards that we need to make sure that we avoid is that we're not cutting closed containers on the CNC plasma cutter because the air inside of them can actually heat up, expand, and cause the container to explode. You have a copy of this in your Learn shell, and if you want to find the safe work procedure for this tool, all you have to do is go and click on this link here or go to the hard copy that we have in the safe work procedure binder in our shop. So how does a CNC plasma cutter work? I want you to think back to a toy that you probably played with when you were young, an Etch-a-Sketch. So this is what an Etch-a-Sketch looks like. You use these wheels here to move around a line that gets drawn on the screen. So let's take a look at how this thing actually works. So you turn those dials to help create that line. But when you pull those dials off and we pull the screen out, we can see below how each one of those dials moves this little pin over. This is exactly what's happening when we're using the CNC plasma cutter. On the CNC plasma cutter, we can only really move in 2 dimensions as well. We can move left to right, which is the X dimension, and we can move up and down, which is the Y dimension. And we call these dimensions axes. For us, it's easiest to create our designs in a vector-based graphics program that isn't on this computer. So once you have that created, what you'll do is you'll go to your computer and you'll type in Flash for FabCut, and you're going to see this green shield here. So if we click on the FabCut app, it's going to bring us to the software that this CNC plasma cutter uses. This is the graphic user interface, or GUI for short, of this program. It consists of 3 stages. So the first stage, which is listed up top, is the CAD stage. CAD stands for Computer Aided Design. This is where you're going to do all of your design work. The second stage is the CAM stage. That stands for Computer Aided Machining. And this is going to be where the computer decides what type of machine you're going to use based off of the design that you've made. This is where all the tool paths are made. And then lastly, we have the CNC stage. CNC stands for Computer Numerically Controlled. And this is where the computer actually talks to the CNC cutter, and it controls it as it's following the tool paths that were created in the CAM stage. Now you can use this CAD section of our program to help make your designs. And there's tons of great videos from FabCut University on how to do this, on how to use these creation tools, the modification tools, and the transform tools. But that's not going to be the purpose of this video. So in order to import one of your designs that you've made with some other vector-based software, you go up to the import section and click on DXF or DWG. You find that on your computer. On mine it already had it preloaded, but let's load it up here. It adds it into your design, and then you press this check mark to check it into your design. Now that we have our design in the computer, what we need to do is we need to then add some tool paths to it so our CNC plasma cutter knows where to cut it out. So in order to do that, we're going to select these arrows here to create a tool path for all of these things to go into the computer aided machining category. So now you can see that all those tool paths have been generated, and if I zoom in, I can actually see even on what side of the line they're going to be cut and how thick the line is that's going to be cut. That's called the kerf. Some of these viewing options are available up here on the right that you can click so you can see how things look when it's about to cut. One helpful tip, if you're looking to move around on the screen here, you can zoom in and out with the scrolling wheel. And if you want to sort of grab the workspace and move to another spot, all you have to do is right click and move the mouse, and that can help you move all around. What you're looking for in this stage here is you're looking to make sure that the computer has decided to cut on the right side of the line. So it's cutting on the waste side of the line, and it's leaving the things that I want. The other thing to look for is to make sure that there isn't any unknown tool paths or anything that's a little bit different than you would expect it to be. You can see that I've turned on the ability for me to see which direction the tool is going to be going in. And you can also see with these dotted lines where the cuts are going to be made or where the torch is going to move from. So you can see it's likely going to start here, and then it's going to move along this dotted line, and it's going to make this cut first, and then this cut, and then it's going to go on forward to that cut, and so on and so forth. Just like in the computer-aided design or CAD section of this program, there's lots of options that we can use up at the top here. And the FabCut University will have a lot of information about that. There is going to be a few things that we need to use up here in these CAM actions. Let me show you what those are. The first setting that you're going to need to look at is, let's click on these cogged wheels. It's a project setting. So the first thing you can do is you can define the workpiece width, the size that you're actually using. And you also are going to define the type of material that you're using. So for us, we are cutting mild steel thickness of this project is going to be 14 gauge. So if I click on 14 gauge, it loads all of the parameters in that we need after that point. If we're using some different cutting, a different cutting head or some different cutting consumables, I can select it from here, or I might need to go into the plasma settings. And in the nozzle here, I could select the type of consumables that I have. And I can also select the type of quality that I'm looking for as I'm cutting these things as well. As is the case with most things in this program, you don't really want to be adjusting any of these numbers here. The computer program itself decides what these should be based off of the settings that we imported. So when we told it that we were cutting mild steel and the thickness was 14 gauge, I'm just going to scroll down and select that, and now I'm going to check that in to apply it. All of these settings that are now in here, if I click on here, all of these settings are the appropriate settings that we need for a cut. So we don't really want to go in and adjust any of these settings. So I'm going to, again, check that in. I can zoom out a little bit using my scroll wheel, move my design by holding right click and moving, and now everything looks good. So what I'm going to do now is I'm going to use these arrows to go to the next stage, which is the CNC stage. Now that I'm here, the graphic user interface looks a fair bit different. Let's talk about what some of these things are. So to start off with these settings, let's take a look at what's on the left-hand side. So there's two options for cutting. We are always going to use this option here, and that is the option that has torque height control. So the computer senses the voltage that is going to the CNC plasma cutter torque head, and it adjusts the height based off of that voltage. We are going to make sure that we are using the touch-off section as well as the kerf crossing detection. All of these settings we're not really going to change. The only one we're going to change is the safe height control, and that one I'm going to get you to put to be 1 inch. So the next step for you is going to be to put your material on the table.